we may be asked to solve a quadratic equation like the one you see right here. Our job is to solve for x, which means getting x all by itself. And the method that we've learned so far is to get the x squared by itself, then kill it off with a square root to cancel that, and then just see what x is equal. Then we remember our plus or minus, things are great. You may think, and don't write this part down here, but you may think the first thing we should do is just get everything away. And now we're going to take the square root of both sides to get just x by itself. And we get x equals this weird looking thing right here. The trouble with doing that is on this problem, this extra x is still hidden in there. We didn't get x by itself, even though it's by itself over here, because there are still x's on this side. It's not possible to do the square root method when you have extra x's hidden in the problem. Because when you try to get x by itself, this guy's still going to be caught in there. He's going to get caught in the square root. So the square root method that we already know and love won't work in this problem, unfortunately. We need a different way to go about it. The key to doing this problem is actually going to be what we learned in our last video with the zero product property. When we factor something, we break it into two little parentheses being multiplied. So if we could take this thing and turn it into two little parentheses here, it's equal to 0, then we can just see what the answers are. So for my magic numbers here, I need two things that are going to add to a positive 11 and multiply to a positive 30. And it ends up being a 6 and 5. Using our little shortcut that we learned, that means my factored answer, because it's just 1x squared here, is going to be x plus 6 times x plus 5. I just rewrote that side, and that's going to be equal to 0 still. Well, now I'm dealing with a situation that's just like the last video. My two answers to this problem are x equals negative 6 and x equals negative 5, and I'm done. I got my answers. If you plug those answers back into this problem up here, they're going to work because we factored it, just rewrote the problem in a different way, and then we were able to get our answers using that nice zero product property. So our basic game plan that I want you guys to follow when you're doing this zero product property, or solving by factoring, I should say. So first thing you want to do is make sure it's set equal to 0. So if it's not equal to 0 here, move stuff over, and then you just factor and use the zero product property. So it's really not a bad process. I have two examples that I want to practice right here using our new strategy. The ones on this slide all of a sudden look a lot tougher. This looks a lot more intimidating than the last problem we were looking at. Totally fine. Remember, you want it to equal 0, otherwise you can't do it. So I'm just going to move everything on the left in this one. So I'll subtract x squared on both sides, I'll subtract 12x on both sides, and I'll add 7 on both sides. All this cancels, so I just get equals 0. And on this side, 2x squared minus 1x squared is going to be just x squared. That's going to be minus 5x plus 4. Now it looks like the last slide once I moved everything over. So, magic numbers, I need two things that add to negative 5 and multiply to positive 4. After thinking about it for a little bit, it turns out the answer is going to be negative 1 and negative 4. You multiply them, you get 4, you add them, you get negative 5. So this is going to factor into x minus 1, x minus 4 equals 0. And my answers are x equals 1 and x equals positive 4. So, final problem for our video. I'm going to go ahead and do the same thing on this one where I get everything over to one side. Plus 3x squared minus 5 on both sides. And when I do that, I get 12x squared minus 27x minus 6 equals 0. Oops, sorry, 15x squared. And at first glance, that does not look pleasant. It looks like it's going to be terrible to solve. And our little shortcut that we got to use in the other two problems isn't going to work here because it's not a 1x squared. But it works like the other problems. It's the same strategy. So I'm going to do my magic numbers here. But actually, before I even do that, there's a GCF I can take out here. And that's going to make my job a little easier because right now I'm going to have big magic numbers. I can actually take out a 3 from everything. And then I'll get 5x squared minus 9x minus 2 equals 0. If you didn't see the GCF there and you just did the problem, it would have worked. It's just extra work to get your answers. So I'm going to make sure my final answer is going to go right here. I'll put the 3 outside, and I'm going to deal with that later. Now I'm going to do my magic numbers. I need two things that add to negative 9 and multiply to 5 times negative 2 is negative 10. Magic numbers end up being negative 10 and 1. So again, I don't care about any of this anymore. I'm just doing magic numbers on this. 5x squared minus 10x plus 1x minus 2. And I'm going to ignore the equals 0 even for now. I'm just going to factor. I apologize, I'm running out of space here. It's getting a little crowded. So we get 5, and then we get x, 5x. I get x minus 2 plus 1, x minus 2. This is going to turn into 5x plus 1. And then x minus 2. So, running out of space, as I said. Almost done, though. I just have to say what numbers make this work. Now, the 3 on the outside here doesn't matter at all. Multiplying by 3 isn't going to get you a 0 anyway, so I can pretty much ignore that 3 when I'm finding my answers. This answer on the right here is the easier of the two to get. It's x equals positive 2. And for this guy, you just do a quick little algebra problem. 5x plus 1 equals 0. You end up with x equals negative 1 over 5. So those are my two solutions.